Good evening, ladies and gentlemen. Thank you for being here. We are a very multidisciplinary team, which we'll see on the next slide, of 3 organizations. We are data engineers, data scientists, data visualizers, are also internationally combining junior and senior knowledge during these last 36 hours. So the main problem we wanted to tackle was actually twofold. We were interested in determining the main factors that are behind the occurrence of mosquitoes, the 2 species of Aedes mosquitoes. But the next step, we were also interested in which factors determine the occurrence of the dengue around the world. And we did it in initially we had the plan to combine coordinates data of mosquito occurrences with population data, climate data to predict the mosquitoes. And then we use that model again to predict the dengue outbreaks. Now, as you can see on the next slide, how we actually solved it, we had some technical difficulties, but we mainly focused on using climate data, as you can see here, and we selected 4 important, according to scientific literature, variables: temperature, rainfall, the number of frost days, and the average number of wet days, which we used to combine and set up a model, as you can see here, indicating on the next slide here, a rough model indicating the prediction or presence of mosquitoes indicated here in orange. Then here on the right you see then the actual data, the actual real occurrences of mosquitoes for 2014. The left, the model was built based on data consisting from 2010 up till 2013. So even when the model was quite general, we see already some nice correlations based on what we see on the map. Now, we also built a model for the dengue cases. Initially, the plan was to combine these 2 models, but the problem was that in lots of the data sets, the climatic data sets and the population data sets, you have different kinds of coordinates, measures, different roundings of decimals. So it's very hard to combine all these aspects of different data sets into one. So we built another data set based on dengue cases from another source. Here you see a map of the world indicating in blue, the countries in blue, the actual number of dengue cases in that particular country. The blue were the more cases. And then we added a model based on factors I will just be explaining in a minute. We put an overlay map, and the size of the circle indicates the actual possibility of dengue in that particular country. And we made, as you can see on the next slide, this prediction on these 4 the most important parameters. You see here that temperature is, again, as we've seen in the other presentations, one of the most important factors determining this variation for dengue and for mosquitoes as well. To just show you how easy it actually is to create maps with data you've received from anywhere, there is a small movie I created, and it seems that it's not working as usual. No, just the movie. We'll put it here through the manual way. So actually, what you need is basically. That's not on the screen yet. Maybe we can start the movie again. So what you need. Oh, no, it's okay. It's okay. You can start the movie again. So what you basically need is just a column with the names of the countries, the names of the cities, or whatever, and on the other hand, a name of your data set consisting of the number of dengue cases. And you see it's just clicking, dropping, and it will create this map for you with whatever data you want to plot on it. Of course, yeah, okay, this again. Of course, yeah, when you do such research, on the next slide, we have encountered a lot of bottlenecks. The problems we encountered were technical, such as losing connection with the network, but also, like I mentioned, these coordinate systems that were different and are difficult to integrate. And also, yeah, we had this problem that the dengue and the mosquito data sets are the presence of data is often there. The absence of data is often non-existent. So it's difficult when you want to model things. The other part of the story is sometimes just missing. We also, by looking at your mistakes, you also discover new things. One of the things here is, for example, a relation between between deforestation and mosquito outbreaks. When you search on Google, just the last slide, please. When you search on Google, you find a lot of studies that may indicate that there is a relation. One explanation for this can be that when you clear cut large areas of forest, the soil gets destroyed as well. And you get these surfaces of water which are ideal breeding habitats for mosquitoes. And for example, the Zika virus has been mentioned by maybe deforestation in Brazil. Now we tested this visually on the next slide. Here you see on the left-hand map of the world indicating the percentage of deforestation. So we see lots of deforestation in Brazil, India, and Indonesia. And surprise, surprise, we have here a number of dengue cases in 2014, so there is some visual correlation going on here. So it's maybe new insight to look into in the future. Then lastly, to sum up, what is the potential impact of what we did? The most important variables explaining mosquitoes and dengue, we see that temperature is a major driver behind it. With global change in our minds, dengue is knocking at the door of Europe as well. And we also may be able to predict regions with an increased risk of infection. Secondly, deforestation may be an additional reason for further outbreaks in deforested areas, as we shown earlier. And lastly, on the last slide, we have the steps that we want to take in the future to improve these models are listed up here. We had these ideas also initially in mind, but yeah, it's a lots of data to implement. But there's still absolutely a positive future for this. I want to end very shortly with the last slide, and I want just to give you a quick update on latest research in controlling sustainably vector control of mosquitoes. They're now experimenting quite successfully with so-called pheromones. These are just chemical pheromones produced by natural predators, natural enemies of mosquitoes, such as the backswimmer over here. These species actually produce these molecules, and mosquitoes are very much able to smell these molecules and avoid laying eggs in these kinds of systems. So one possible is, and the nice thing is that the molecule is very easily and cheaply made. So this may be another cost-efficient way in controlling vector mosquito control on a sustainable way. So by this, I want to thank you. I want to thank you, the organization, for giving us the chance to be here, meet interesting new people. Also, the people from Xplodata for supporting us with the technical details. And thank you for your attention.